Okay, let's get started. Hi everyone, great to be here again. Last time was 2018. I don't remember if I spoke about Bluetooth then, but probably because I've been doing that for a while now. So this is a talk that I'm kind of repeating as I learn more and as Google tries to fix things and new stuff appears, basically. So let's start just like, who here works with Bluetooth Low Energy on Android? Yeah, most of you. So the rest of you have an experience to look forward to. So you know a lot of the problems here. You know why I'm doing this talk, and like you're hoping to maybe learn some new stuff. So, quick history of this. So we've actually had the APIs for Bluetooth Low Energy since 2013, so it's 10 years. Are they working still? Yet, rather? Barely. They made some changes in API level 21 for the scanning part, so not the communication part. And in API level 26, that's Android 8, they introduced BLE 5.0. It's a very big change, actually, in the Bluetooth communication parts. And they added some new APIs there. But most importantly, they added the companion device manager, which is a crucial part of actually setting up the pairing between your device and your app. And in API level 31, they extended this with the companion device service, which is also an important thing to keep track of. So those important changes. And the most important changes is that in API level 33, they made some major API changes to how the Bluetooth GATT works, which is really, really important to understand these days, because if you don't, your app will basically stop working on, later Android versions. Okay. Challenges. Those of you who work here, you know this. There are bugs a little bit all over the place. There's a system behavior that is undocumented, which causes more bugs. There are race conditions in the whole API, so that is also unknown to most people, which can even more bugs. And then testing is complicated because you can't really use the emulator, and you're setting up the device and running that one. It's basically hard to do. There have been improvements here, both from Google. They are adding some instrumentation APIs for the emulator so that you can instrument how the Bluetooth APIs will react. It's a Python API, but still. That one you would run beside your instrumentation test, basically. And then there are Roboelectric is adding support for Bluetooth GATT APIs in the next upcoming version. Emulators, well, I said there doesn't exist any emulation for the Bluetooth stuff at all at the moment. It is coming, but it's not prime time ready yet. So yeah, so the first takeaway from this today is to not do Bluetooth Low Energy below Android 8.0. Just avoid it. It's not worth it. And Android 8 is so old these days, so you shouldn't have a problem bumping your Min SDK to that. Now, if you still have to do it on lower versions, good luck. You still use the same things. You don't use a companion device manager, so you don't have that one, but you still can do the search and scanning and stuff like that. But I strongly advise you to try to bump up Min SDK to 26, at least. Now, over the years, there have been a bunch of myths about how to do Bluetooth Low Energy on Android, and I'm gonna poke some holes on those. Some of these have been told by myself, which I've learned later that they were wrong. So you live and you learn. First of all, there is the fact many people say you have to run the BLE stuff on the main thread. No, not at all. Doesn't matter. And also, it doesn't matter if you run it on the background thread either. It's completely irrelevant which thread you call the Bluetooth GATT operations on. It doesn't matter. The callbacks doesn't happen on a background thread. The callbacks happen on a thread which is not safe to do much stuff on, so you should move out of that thread as soon as possible. It's a binder thread. I'm not going to go through what binder are much today, but basically you have to take the values to do that, and you have to leave that callback as soon as possible. Do not block it, don't do stuff there, etc. You can use a handler, and this is where I was wrong. I thought that was a good addition to the APIs, but you can use a handler to the Bluetooth GATT callbacks So all callbacks happen on that handler, which is a very bad idea, as I'm going to tell you later. So don't use that one. The Bluetooth GATT characteristics, which is the actual value object, which we read and write from, is thread safe. That's an assumption that we have. We see that in the libraries. It's not. Do not keep references to these objects, ever. Operations are queued safely, so if you do 3 consecutive writes, that will work, right? No, it won't. It will probably fail unless you explicitly tell it not to wait for callbacks. And well, I'm safe if I use one of these libraries, right? The popular ones are RxBLE, RxAndroidBLE, and Cable, which is a new one. None of these take care of the bugs that are mentioned above here. Well, they do queue operations, but that's basically what they take care of. Requirements. Whenever you're doing Bluetooth Low Energy today, you have to use a companion device manager, unless you are actually literally only using BLE when the app is in foreground and never ever otherwise. But you have to use, if you're doing any background operations or assume that you will keep the connection to the device when the user leaves your app, you need to use companion device manager. There is no other option. You need a foreground service in some way, especially from Android 12. So you need to understand how foreground services work. A good thing to understand here also is understanding the difference between pairing and bonding in the BLE, the Bluetooth sense. And then there is the very famous autoconnect parameter here. So who here has autoconnect set to true in your code? One person only. Okay. Who has it to false? Okay, so the rest of you don't know really, maybe. So the thing is, like, I get it that people have tried different things here. The truth is you're going to use both. We're going to come to that later. So, and then one important thing here to understand also is the constant write type no response. What does that mean? When should you use it? Why is it good to understand? And again, don't keep a reference to Bluetooth GATT characteristic. Best practices. Let's go through how Companion Device Manager works. This code is just small snippets of it. It works for when your UI is compose, but it's fairly easy to use once you get the hang of it. You create an association request. You do it like this. In this case, I filter on the name, which is a bad practice. You probably want to filter on a service UUID instead. You can also create a filter which is specific for a specific device with a hardware address. And then a good thing to remember, if you have an existing app with existing users, and you want to set up the Companion Device Manager because you haven't done so, you can use this set single device to true, which will shortcut the whole companion device process to be much smoother for the user. You already know the device address, you run through this, and you just get one single click dialog. So it's easier for the user, and your UX designers will like you. Because it's kind of bad UX for this one today. You have a callback where you have an on-device found and then failure. You get the Companion Device Manager system service, and you call associate with the request, callback, and the handler. The handler can be whatever thread. It doesn't really matter. And then you launch this. You launch this with a request launcher, which basically activates the whole system process for granting you the permissions and setting up the association with your device and doing the search in the background in the system services. So the search for the device that you're pairing with is not done in your app, it's done by the system. And then when this is finished, you get a Bluetooth device and then you can connect to it. The great thing with this, it looks like this then. So if you haven't tried it, this is what you're going to see. Depending on Android version and OEM, because it changes a little bit. Why do we need it then? Well, there are these permissions, and they're adding more in each Android version. The most important ones are the 3 top ones. Run in background. Run in background is the only permission that will grant you the possibility to start a foreground service from the background. That means when you come close to your device, you're not connected, you come close to the device, you have something reacting to that one, whether it is the companion device service or you're doing Bluetooth LE scanning with a pending intent. That one will allow you to start a foreground service in the background. There is no other option. There is no way to go to bypass this anyway. So yeah, you have to have that one. Use data in background. Well, of course, if you want to make network calls while you're running in the background, you need that one. Third one, request self-manage. If you have an existing app, you haven't set up the companion device manager for your users, that one is good because that lets you assign the association manually in the shortcut way. And this one, the start foreground service from background, that one is actually not needed because it's implied if you have companion run in background. This one is if you only have short connections. You just connect when it appears, and you do something within a minute, and then you disconnect again. Then you can use this one. Probably you still want that one, though, because you never know how long things take. And the rest of these are permissions that you will need in later Android versions to tell the system what kind of companion app you are. So once you have this pairing done, another perk of it is that you can get the device address. So you don't need to track the hardware address for your peripheral anymore. You can use the companion device manager. And a bonus for that one is that if you get an empty array back, if you don't get a result back, then you know you're not paired, and you need to redo that again, because then you don't have the permissions to run in the background. So checking whether you have an association or not is something you should always do, so that you can repeat the pairing process if it's been lost for some reason. The user cleared the data or something. Yep, okay. So bonding is a thing that you have to do manually, except for the cases where you have an encrypted characteristic. Then it's done automatically once you read that one. But I recommend everyone to do this step either way. So if you have a Bluetooth device, you will most likely need to do Bluetooth bonding. You need to call create bond on that device. What does bonding mean? Well, pairing, in this sense of Android, only has to do with Android. It doesn't have anything to do with Bluetooth per se. It only has to do with getting the device address so that you can connect to it later. Setting up the companion device manager so you get the permissions. Bonding is about having the encryption keys that are involved in any Bluetooth communication and persist those so that they are stored on the device so that the next connection attempt goes faster. And the way to do it is basically like this. We create a data class that represents the state and the device. We use a callback flow where we create the receiver, intent filter, and then we send out the current state on this flow. And once the flow is like we unsubscribe, we will unregister the receiver. These slides will be up on speaker deck afterwards. You will see the link. So it looks like that. And the way you use it is basically like this. So you have the three states, and you just call create bond, and then the user will get the dialog popping up saying, do you want to pair with this one? So the naming is weird. You create a bond, but the dialog says pair. So don't worry about it. Users will never see your code. So, but it makes for an annoying case, because you first have the system dialog with a companion device manager that you have to use, and then you get the dialog with the bonding dialog, which says pair. So it is a confusing thing. I've addressed this with Google. They are thinking about it, maybe in Android 16, 15, I don't know. We'll see. Okay, you have created the bond. So users maybe want to remove the device, and you give the users, like, tell them, go into the Bluetooth settings and remove the device from there. That's in many of the apps that are companion apps. This is a common instruction. Maybe you provide the intent to go there quickly so the user can remove it, but you can actually remove it yourself and provide a better user experience. If the user does not remove it, they will have stale keys on their phone, so they can't connect again, which ends up in a very weird user scenario. So you need to provide this one. And the only way to do this, because this is a hidden API. It's not a system API. You are allowed to call it, but you need to use reflections to call this. Okay. And then you register, and then comes companion device service. So once you have companion device manager set up, the pairing set up and everything, you need something that reacts when the device is nearby so that you can initiate the connection. And from API level 31, Android 12, you should use the companion device service. You register your service like this. Remember the permissions, remember the intent filter. And the only thing your companion device service actually needs to do is this. In the on-device appeared, you extend the companion device service, and in on-device appeared, you call start foreground service, so that your app keeps running. And then you need to know and understand how foreground services work, but I'm not going to go into that here. So this is just a simple version of this one. You probably want to add more with that, like starting the connection and everything like that. So we update our register activity for result that we saw earlier, where you actually call companion device manager start observing device presence. Remember, if the user removes the device from your app, you need to call stop observing device presence as well. And also do the remove binding. So if you're below Android 12, what do you do then? Well, then you have to use the Bluetooth LA scanner in order to detect when the device is nearby. Most of you probably do this already. This also works after, like on Android 12 and later, but I recommend using companion device service because that's what Google is gonna push people to. So you will need to use have both of these implemented. And this one is like a little bit more things to set up. You create a scan filter, you can create some scan settings. You can have a scan filter that where you just have a device address, because you know that one already. And then play around with the scan modes. They make a difference when it comes to battery performance of like how much battery is consumed. Low latency consumes the most. Maybe you want a balanced one, and so on. You maybe want the callback type first match, so you only get one match when it's found, because you only have one device. And then this set legacy is the type of announcements that your device is making. If you have a device that supports, that uses Bluetooth 4 and not Bluetooth 5, you need to have set legacy to true. True is also the default. If you know it's only on Android 5, or sorry, Bluetooth 5, then you can set it to false, and you get a better performance for the whole scanning. And once you have that, you create the intent pointing to your broadcast receiver. It needs to be a broadcast receiver. Sorry, you can't start a service directly because that won't allow you to start in the foreground in a smart way. So you have that one, and you create a pending intent, and then you say start scan and passing all these parameters in. In your broadcast receiver, the only thing you need to do is say context start foreground service with your intent. You don't need to extract the Bluetooth device that comes in this. Why not? Well, we already know the Bluetooth address, so we can get that later if we want to. So it only has to be this much. So yeah, you have to step through a broadcast receiver in order to start your foreground service in this way. And this only works from Android 12 and forward, if you use this on Android 12 and forward, if you have the companion device association set up. It's not enough to just have the permissions. You actually have to have a working association. On Android 8 to 11, it works out of the box. I mentioned foreground services a lot. I wrote a blog post about that one. Not going to go in deeper to that one. So if you're interested in the limitations and the requirements and the challenges with that, check this one out. So Bluetooth GATT has this structure. Most of you who work with this know what I'm talking about. You have a Bluetooth service, which is a grouping of Bluetooth characteristics. The characteristics work as endpoints, basically, with a data stored. And each characteristic has at least one descriptor. And the descriptor is how you configure this characteristic. So the two common GATT designs for peripherals are these two. You design a sort of message bus where you have two characteristics, one for reading and one for writing, and you never do explicit reads on it. Instead, you enable notifications, so you get the data pushed to you, and then you keep writing on the other one. So it sort of works like a message bus that way. So you send these byte array messages through that one. That one works, but it has some challenges because you only have 1 megabit per second. It's actually, in practice, you probably have less than that, probably like half a megabit, for various reasons. I'm going to look at how we can tweak this later. But it's easy to choke the connection, so you send too fast. And the error handling there is not great. The other way to do it is that basically every data point on your peripheral has 1 or 2 characteristics, depending on if you can write to it or not. That's a more common design when you're working with like a Bluetooth sensor or something like that, a scale or something like that. Then they usually have like multiple characteristics for each type of data point on that device. So those are the two designs. I will not say which one is better. They both have challenges. This one has more, you have to work with more characteristics. This one is like sensitive to sending data too fast. Yeah. Operations, you connect, you discover services, which is the first common mistake if you forget to do that one. You register for notifications, which has a very peculiar API, and then you do the reading and writing, and then you have to, on Android, remember to call both disconnect and close. If you forget to call close, you will leak a reference, and you will keep getting callbacks on your Bluetooth GATT callback. And it's important to understand how this is designed. So you call operations on the Bluetooth GATT object, you get callbacks on the Bluetooth GATT callback. All of this is then passed over the binder. You know what the AIDLs are. Basically, that's happening underneath here. And you're getting callbacks on the binder as well. There is not one binder thread, it's a thread pool of multiple threads. Okay? So this is a shared thread pool where these calls happen in your app. This also means that there can be multiple devices speaking to multiple apps speaking to the same peripheral. So if you have if a user has installed a Bluetooth app that does weird things, it can interfere with your communication. Yep. Now, this is the famous method that many people get stuck on. Well, the context, of course, it should be an application, not activity. Autoconnect is badly named. The name should be indirect. That's better naming, because that's what it implies. If you have it to true, it means that you allow the peripheral to connect to your phone. If it's set to false, it means that you make a single connection attempt to the peripheral from the phone. So false is faster, but means it will only try once. If you set it to true, it will wait until the peripheral connects. Okay? So, and then you pass a callback. Do not reuse the callback. So when you disconnect and close, don't reuse this object. And then on the final parameter, the callbacks where you can say that I want the callbacks happening on a handler thread. Don't use that. There are memory safety issues here. The GATT callback, how to do it, how I do it today, is basically I extend it, and inside I have a mutable shared flow, which I then expose like this. I hear they're going to fix that in new Kotlin versions, you only need one. But this is where your app will read events from the peripheral. And then you have all your callbacks. I create the event classes that wrap the callbacks. So it's basically for a read, for instance, I have that one. For a changed, I have that one. I don't keep the Bluetooth GATT characteristics. I only keep the UUIDs. Don't keep the Bluetooth GATT characteristics object. And then, like in the read callback, this is the new version of the API. So in the old version, you don't have the value parameter. So what you do here, you take the characteristic read and you create an event and then you emit it on the flow. And this is the safest way to work with the Bluetooth GATT callback. This is basically what RX versions of these libraries out there already do, but this is a Kotlin version. The cable library, I think, do similar way. Well, they changed, look the same thing there. Now, the deprecated callbacks. So added in API level 18, deprecated API level 33, it has 2 parameters for on-characteristic changed, because it's not memory safe. Because you have multiple binder threads, and if you get multiple changes, you get changes quickly from the peripheral. Since the Bluetooth GATT characteristic object is shared between all threads, the value parameter in that object might be overwritten before you read it in your thread. And that is why there is a bug in the Android API that is not possible to fix. There is no workaround that is completely 100% safe. So the new version looks like that, where they, in the binder thread where they get the value, they pass it into your callback like this instead. So you get the actual value there. So it can't be overwritten. Which is great. So from Android 13, you have the memory safety, but you don't on earlier versions. So you need to implement this. If you haven't implemented this callback, you're relying on the old one. Bad luck. Go fix that. So how do you deal it before API level 33? Don't use a handler, because then you involve yet another thread, because then you will pass data from the binder thread to your handler thread, and then you're going to read it. So there's an extra step there, which increases the risk of the memory safety bug occurring. Don't use the same characteristic for read and write. Usually, the characteristics are divided up, one for reading and one for writing. But if your system designer for the IoT designers or whatever people design the peripheral did it badly, you might have only one, which is used for both. So then you should go talk to them and see if you can get a firmware update. And don't retain the Bluetooth GATT characteristic objects. This will just reduce the risk for this happening. It can still happen. It's unlikely if you follow these things, but it might happen. I don't have any better advice, though, so we'll see. How do you queue operations? So a common mistake is that you connect, and then immediately you call discover services. And sometimes it works, and sometimes it doesn't. That is because you're not connected yet. So every Bluetooth GATT operation, connect, read, write, etc., you need to wait for the callback to occur. How can we do that in a safe way? So another problem is if you have 2 characteristics. You write to one, and then you expect the change to happen on the peripheral. So you write to this one telling that to enable the temperature sensor. That's a common way to do this. And then you read from the temperature sensor. And this works sometimes, but sometimes not, because the callback hasn't happened yet. How to queue? We'll use a mutex from the coroutine library. So we add an extension function called queue with timeout. It does exactly like that. We have a timeout value as well, so that we don't end up in a deadlock. And then we have a suspending function for what we actually are going to do. And then we say with this mutex, with the lock, so it will basically lock this call here, so no other user of this queue with timeout, they will stop here. And then with timeout, you give it a timeout, and then you call the block. This is how we queue it up. So how do we use that? Well, let's write our own write characteristic method. So we call the mutex queue with timeout. We have the events coming from the Bluetooth GATT callback that we saw earlier. And we say, on the subscription, then we do our actual call to the Bluetooth GATT object. Here we say write characteristic. And then we say first or null on these events that matches characteristic written and matches the UUID. And if not, we say failure. If it happens a timeout, you will get a timeout exception here. So you might want to catch that one, or depending on your own logic, how you want to deal with that. So this is how you safely queue the operation. So now you can actually call write several times, and it will safely wait until then. And you will get the event back on that one instead. So now you can do things like this in our wrapper. You say connect and write. You connect, it's called discover services. You say you find the characteristic you want to work with, and you write to it, and then you disconnect and close. This will always work. This will be safe. Well, pending timeouts because you couldn't connect or something. But anyway, so this is how you do this. There are other variations of this, but basically this is what you probably need to do it safely. So connection strategy, going into that one. So auto-connect false, you start with that one, which means try to connect immediately. So once you have gotten a callback saying, okay, the device is nearby, if it's a companion device service or if it's a Bluetooth LE scanner that started your broadcast, you say, auto-connect false, try immediately. That will be the fastest way to connect. So shortest delay for the user. If that connection fails, like you get a timeout or you get a callback saying failed, then you try again with auto-connect true, where you tell the device, okay, wait for the peripheral to connect instead. Let's do an indirect connection. And if the second fails, then its connection is probably not possible. So do we get the auto-connect parameter better now? I hope so. Notifications, and this is this one is tricky because it's so badly documented, not only for Android, but overall how it works and what's needed. On Android, they have added extra complexity just to make us confused. So what you need to do is you need to first take your Bluetooth GATT and say set characteristic notification with that characteristic and set it to true. This does not enable notifications on the peripheral. All it does is tell the system service that your app is interested in notifications getting pushed by the peripheral to be delivered to your app so that you get the on characteristic changed. That's just the setup between you and the system, not the peripheral itself. Now, you have to get the descriptors from the characteristic. You have to find the client characteristic configuration, which is a UUID, very badly documented. You can find it in the Bluetooth spec. I think it's a couple of thousand pages. Once you find that one, you set the value to it. At least they have a constant in the Android APIs to enable notification value. There is also enable indication value, rarely used, so just use enable notification value. And then you say Bluetooth GATT write descriptor, and you write to that descriptor. Okay, simple enough. What is the client characteristic configuration? I share it here because it's hard to find it. This is the value. It's always this value. I don't know why they didn't add a constant. It can theoretically be a different value if the people who designed the peripheral did it badly, because it's just a UUID basically. But this is a well-known UUID called in the Bluetooth world. Okay. Faster write operations. That would be nice, right? So you can actually skip the callback by saying the write type to write type no response. Then you won't get any callback, and then you can try to write as fast as possible. But it might fail also, because if you write too fast, you will choke the connection, and you will get an error code printed in logcat saying a weird error number. If you go into AOSP, you can find it that says congestion or something like that. Yeah. Anyway, so this is how you can do it. It's useful for when you're doing OTA updates or if you're doing the message bus design of your characteristic, where you actually just send data continuously. So another way to do faster operations is using the PHY options, which was introduced in Bluetooth 5, so that only works on Android 8 and later. and if your device supports Android Bluetooth 5. You have two options, basically. You can get long range and very low bandwidth. And the way to do it is to say Bluetooth device.phi LE coded mask, and then you also add the default one, which is 1 megabit. So you want LE coded. And then you give it an option. I'm going to explain what this means. And then you call Bluetooth get set preferred phi. Why is it done twice? Well, you can set it both for receiving and transmitting. So RX, TX, basically. And then the options. So what does this do? When you use LE coded, you increase the number of bits used for error correction on the physical layer of Bluetooth, basically. Phi option S8 tells you how many signals it's going to use. Signals is almost equivalent to bits, not really, but think of it like that. So how much it should use, basically. This means you get less data to transfer in each message, which will reduce your throughput. Got it? So you get a longer range, lower throughput. So if you have a device which will maybe be far away from the phone, like a smartwatch, for instance, the user left the phone there and walked away, and you still want to retain a connection, and you really don't care about fast throughput, this is a good option. It also might be useful if you're working with, like you have a lot of devices outdoors or something like that, and you want to reach them fast. The other way is to use the 2M mask. And then you don't need an options, because there's no options there. It's basically what it does is reduce the number of bits used for error correction, and there's more data, you get faster throughput. Shorter range, faster throughput, longer range, lower throughput. Nice. Not supported by all devices. There is no API in iOS, although iOS does support it underneath, so the device, the peripheral, can request it instead. And it's just a request, it's not a guarantee. You will get a callback telling you what the phi actually ended up being. But this is a good thing to add if your device supports it, Bluetooth 5 or later. Common pitfalls then. You didn't call discover services. Like, I've been doing this for 10 years now, still sometimes forget it. You're not queuing your operations. Now you know how. You don't need to do exactly like I do, but you can at least mimic that type. Retaining any of the Bluetooth GATT characteristic, descriptor, or service objects is not safe. Don't do it. Just fetch them from the Bluetooth GATT every time instead. Easily to misunderstand how autoconnect works, because autoconnect is a bad name for that one. And then you reuse the callback. It's also very bad. And you didn't call both disconnect and close. If you don't call close, the close should actually be called unregister or unsubscribe. What it does is remove the callback from the Bluetooth system, so you're no longer getting the callbacks there. Disconnect will just disconnect. How is the future looking? There might be an Android X library. They are talking about it. It's early days. Maybe we'll hear something at Google I/O. You will need to use Companion Device Manager and Companion Device Service. It's probably going to be mandatory for any companion app in the future, so just get started with it now. You need the companion device type registration in your manifest. That's going to be even harsher requirements for that in Android 14. So if you thought foreground services was hard from Android 12, it's going to get even harder and even more restrictions. Another thing that might happen, and it does already on iOS, is hardware address restriction. They might start hiding that one. So you're getting a unique ID instead. So that might also be a reason why you should use a companion device manager, because then you will be future-proofed for this. Okay, 5 minutes left. Summary, yes, you've already seen this. And thank you very much. You can find these slides here. I will upload an updated version there soon.